Hi, welcome back to another Robochargers CAD class video. Um, this summer we're going to be releasing just a few extra videos on some topics that didn't really fit well into the class last summer. Um, I don't know exactly how many we're going to do, but we're going to be releasing these periodically as we get them done and as these topics come up. So what we're going to start off with this first video is we're going to talk about the onboarding process from another CAD package to Onshape in the context of FRC. Um, this video is primarily targeted at experienced CAD users, people that have been using CAD for years and years and are considering switching to Onshape or need to use Onshape for FRC. If you're a beginner, there's probably going to be a lot of stuff in this video that's not super relevant to you. And so this video is totally optional. If you are familiar enough with Onshape to be watching a video about it like this, you might already be familiar with kind of the advantages of Onshape for FRC, but I'm going to run through kind of the reasons why you would want to switch to Onshape. The biggest one is the ability to share files. Onshape is essentially Google Docs for CAD. That's the very high level way of explaining it. It's completely browser based, and everything is stored on the cloud, and so you don't need a server or a network drive or some way of handing files back and forth between local machines to share files. That is the biggest reason to use Onshape for FRC. In addition, because it's browser based, it's very easy for students to access. And beyond that, the ability of Onshape to model FRC and FTC robots specifically is very well suited to the kind of workflow that competitive robotics teams need to use. The very fast development of the mechanical designs and some of the types of geometry that you're going to see on your robots, Onshape is very well suited to modeling those things in a very efficient manner. I'm not going to go into too much detail on that, but I will just say that in my experience, you can model a robot significantly faster in Onshape than you can in any other CAD package that I've used, and the difference is not small. So with that in mind, I'm going to be focusing primarily on switching from SolidWorks and Autodesk Inventor to Onshape, primarily because those are the two CAD packages outside of Onshape that I have the most experience with. However, those are also two of the most common CAD packages in FRC. There are several other ones. I'm not really going to touch on Fusion 360 as much because I don't think it's quite as common in FRC as it is in FTC. And in general, the changeover process from Fusion 360 to Onshape should be a little bit easier because they share some of the same conceptual paradigms, I guess. All right, so before you really get into like this video, you'll need to go back and watch the first part of the first episode of the CAD class from last summer. I go over how you create an account, how you get it upgraded to an education status, and I go over to how to install some of the plugins and add-ins and things. I'm going to be kind of assuming that a lot of that stuff is already in place for you in this video, and I'm not going to go over that process again because it'll be very redundant. So like I said, when you start off in Onshape, the way to think about it is that it's Google Docs for CAD. A lot of the similar paradigms and things exist in terms of the way that quote unquote files are managed and sharing and things like that. What I'm showing you here is the main screen that shows up when Onshape, when you open Onshape in the browser. I recommend setting your bookmark to cad.onshape.com. If you just go to onshape.com, you've got to click through a couple of different menus before you actually get to the CAD interface. So let's talk a little bit about how the file structure works to start at a very high level. Everything you do is going to be in what's called a document. Um, the biggest difference in this regard from other CAD programs is CAD programs like Solidworks and Inventor have different types of files. They have part files, drawing files, assemblies, things like that. Everything in Onshape happens in a document. In addition to that, you can organize documents into folders. You can share documents with organizations. And there's a lot of different ways to keep things organized. The big thing that's a little bit confusing when you start off is that when you create a document, you don't necessarily have to create it in a folder. In addition to that, there is no root folder that you store things in. Stuff will show up on this interface based on who owns them, like who created the document or who has ownership. Just like in Google Docs, you can transfer ownership between documents, and they will kind of move around like that. The biggest thing that is probably confusing about this is when you create a team. You will create a team for your, FRC team. You can be a part of multiple teams. You can have admins on teams and things like that. I'm not going to go through really the process of creating a team and maintaining one. There's lots of other good documentation about that. However, the thing to understand is that when you click on a team, you're going to get this kind of interface here. This appears like I clicked into a folder. However, that's not actually what's happening. These are just, it's doing is listing all of the documents that are shared with this team. And so as long as you keep that in mind, that when you click into a space like owned by me or created by me or shared with me or teams, you can see documents in more than one place. What you're clicking on over here is not actually a folder. It's not a root folder that you're storing stuff in. It's actually just, it's more like a filter, and you're viewing things by who they're shared with. All right, so to create a document, it's pretty straightforward. You just go up and you hit create, and you click document. You give it a name. You can always change this name later. And you can also change ownership if you want to. You can also assign labels, and those can be used to filter documents by what they're used for. However you want to use the labels, you can. So I'm going to create this, and then once you create a document, it'll take you to the actual CAD-like UI. The best way to think about a document is not that the document is a file that represents a part or an assembly or something. The best way to think about a document is that a document is a project. You'll have the most success if you picture it that way, and you'll tend to use better organizational techniques if you just think about a document as a project. There's several different ways to use documents, especially in the context of FRC and FTC. Generally speaking, you can break up a robot into subsystems very easily. And so one of the ways to organize your robot project is to put each subsystem in a document, and then maybe have a separate document that's the full robot assembly. That's one way to do it. Another way to do it is to just store everything for the entire robot in one document. Now, in order to determine which one of those you want to do, you've got to keep performance in mind. If you store very complicated stuff in a document, that document will get very slow. And so, generally speaking, you want to try to break up more complicated projects if you can. Now, for things like FTC, where the robots are a little smaller, a little simpler, not necessarily so many fasteners and just little detail things in the model, it is viable to store them all in one document. Like, that document will be usable. In addition, the situations where you want to store everything in one document is where There's a lot of very, very close relationships between the parts. When you're designing an FTC robot, obviously the robots are very small, but the components are still relatively large. And so FTC becomes a packaging problem, and you need the ability to fit separate subsystems around each other. And the iteration time on that process is very short. And so typically for FTC robots, I prefer to put them in a single document because it makes that workflow of packaging a lot easier. For an FRC robot, I definitely recommend that you separate it out so that each subsystem is a document, and then you have a document for the overall robot assembly. We are probably, in these extra CAD videos that we're doing, we're probably going to create a video all about how to structure a robot project. There might be more than one video, actually. That's one of the more advanced topics that I really want to get into. So I'm not going to go into any more detail than what I've said here, but stay tuned for a future video about that topic. So let's go over kind of what we're looking at here. Down at the bottom, we've got a bar that has tabs. You can see there's a Part Studio and an assembly. I'll get into exactly what those are here in a second. Along the top, you've got your tools. You've got a drop down all the way at the top with some options for the document itself. You can rename by clicking in this box, very similar to like Google Docs. There's a few buttons on the side, which we'll get into later. And then this pane right here is the feature tree. And then down at the bottom, we see some parts, which we'll get into how that works in a little bit. Over here, we've got an assembly, which also has a similar tree to the Part Studio. Navigation tools in the viewport, and some of these buttons on the side, which we'll touch on briefly. One of the things to look at over here is this little button down in the far left-hand corner called the Tab Manager. If you click on that, it expands this pane and it shows the tabs you can see down at the bottom. However, it shows it in a slightly more normal folder structure view. If I create a whole bunch of tabs, I can create subfolders here. There's lots of different kinds of tabs, which we'll touch on briefly later. And if you get a lot of tabs, which can happen in complicated documents, it gets a little bit tricky to navigate down here on this bar. So using this kind of folder view is a little easier, I find sometimes. Okay, so I'm going to talk about kind of the elephant in the room to start off is the Part Studio. The Part Studio is one of the big things that catches people off guard when they start in Onshape. So it's important to kind of address it. So in Onshape, every part is created in a Part Studio. The idea of a Part Studio is that a lot of parts are dependent on each other. And so there's no reason to create parts in separate files like you'll see in most CAD programs if those parts are closely related to each other and depend on geometry. If you think about it, every part that you make essentially has to attach to something else, and that interface has to match up, obviously. And so Part Studios allow you to create multiple parts in the same environment using a common feature tree. In general, for advanced CAD users, you will find this workflow is essentially the same as a multi-body part in Solidworks or Inventor. A lot of the tools and the paradigms and the workflow is the same. However, Onshape takes it a step further and just makes those into entirely separate parts. Let's go over some quick modeling stuff. The actual part modeling process is not a whole lot different from SolidWorks or Inventor. You've got a feature tree over here, which works the same way that it does in SolidWorks Inventor, roughly speaking. Once you get a couple more features in here, I'll show a few of the controls. The viewport works the same way it does in most CAD programs. The default navigation for Onshape is middle mouse button drag pans, right mouse button orbits, scroll wheel zooms, and you can reverse the direction of the scroll wheel zoom if you want to. All of this stuff is in your preferences for your account, which you access up in your little user button up here. There are presets for different CAD programs like Inventor and Solidworks. So if you're coming from another CAD program, you can just select one of those presets and it'll set the viewport controls and scroll direction and everything to whatever default matches that CAD program. So SolidWorks users are typically used to orbiting with the middle mouse button. There's a preset for that. You can just change it. If you're used to that workflow, if that set of controls, right, there's not really any reason to learn the Onshape defaults if you can just change it. That's one of the things that's very nice, switching between Inventor and SolidWorks and vice versa. There's not really any way to change those CAD programs. In a more recent version of Inventor added that ability to switch the controls, but SolidWorks still stubbornly refuses to allow you to configure that, which is a very annoying feature. Okay, so and then you've got a little cube up here in the corner, and you can go to the predefined views as you want by just by clicking on them. There's also this little drop down which allows you to do things like changing to wireframe and hidden edges, doing section views, stuff like that. Going to predefined 3D views, all that stuff. It's not really any different than SolidWorks or Inventor. It's just reorganized in a slightly different position on the screen. Okay, sketches. Very similar. You hit the sketch button and pick a plane, or vice versa. You can pick a plane and then hit the sketch button. The sketch will create this kind of ghost plane that you can see. It's a little annoying if you create a sketch on a plane that it looks like there's two planes there now. It just kind of clutters the screen, but if you're creating it on a piece of part geometry, it can be helpful. One of the things that's kind of confusing when you start off is this sketch dialog just stays open while you're working on the sketch. It's very tempting to like create the sketch and then click OK, but if you click OK, it just exits the sketch and you can't edit the sketch anymore. So that dialog just stays open. You can move it around and get it out of your way if you need to. Other than that, I mean, geometry creation is relatively straightforward. You can see the sketch shows up in the feature tree. If you want to hide these planes, every item in the feature tree, if you hover over it, has this little eye. If you click on that, it'll toggle the visibility. So you can hide these planes. If you want to, you can hide individual features or parts or whatever if you need to as well. Geometry creation is pretty straightforward. It's very similar to SolidWorks or Inventor. The only key difference that I think throws people off and throws me off occasionally as well, even after I've been using it for a while, is normally if you create a piece of geometry like this in SolidWorks and Inventor, I could just start typing and it would edit these dimensions that are showing up on screen. In Onshape, you have to click first and actually place one vertex of the shape, right? And then you have the ability to enter your dimensions. If you hit enter, it'll switch to the next one. You can type in both, just like I did there. Constraints work a little bit more like they do in Inventor than SolidWorks. So if you're coming from an Inventor, the constraints won't really throw you off. If you're coming from SolidWorks, the workflow is a little different. So if I want to, make a circle and I want to make a line that's tangent to it, normally in SolidWorks you would select both of these. It would show up on the side. You'd click which one you want, and then it would apply that constraint. In Inventor, you've got more of this toolbar style approach where you can click tangent, then click the two pieces of geometry, or if I Control Z, I can also select the two pieces of geometry and then click the tangent button. Either workflow works. So Inventor users, this is pretty much exactly the same. SolidWorks users, this is a slightly different workflow. Luckily, you can still select your geometry and then click the constraint, which is slightly similar to SolidWorks' workflow if it's slightly different. One of the biggest, probably one of the top annoyances that people switching to Onshape will have is the selection style. So if I click on like this circle, and then I go over here and click on the line, you'll notice both pieces of geometry stay selected. That throws a lot of new users off. because the kind of typical way that that works is when I select another thing, it deselects the first thing I selected unless I hold like Control or Shift. In Onshape, just if you just keep selecting, it'll just keep selecting things until you click into white space. If you need to deselect everything quickly, the easiest way to do that is to hit the space bar. I will find sometimes that clicking into white space doesn't always work on the first click. I don't know why. I think it's a bug and it usually works, but sometimes doesn't. And so space bar is a much more reliable way to just deselect everything. You can also select different types of geometry and whatever if you need to. This applies in sketches, this applies in part studios, this applies in assemblies, this applies everywhere. A couple of other little design notes. These dialogues are pretty common across all of Onshape. The style and kind of way of interacting with these dialogues is consistent across all the tools. There's actually a reason for this, which I'll go into at the end of the video. You'll notice that anytime you have to make a selection on screen in order to input data into these dialogues, they have these little rectangular boxes. If you click on them, they highlight blue. They can store multiple selections in some cases. If you're familiar with SolidWorks, this kind of like box to make selections is a pretty consistent piece of design language. In Inventor, this is not really quite so common, but it's essentially just a list of the things that you've selected. And so this is pretty consistent across all of the tools. So let's exit out of this and delete some stuff here. Other tools like Extrude are pretty much the same as they are in SolidWorks or Inventor. Once again, you've got one of these selection boxes that you can use to select your regions. I'm actually going to edit this and add a circle, you can set your default, this is defaulting to inches. You can set your default units in your user preferences as well. If I go to extrude now, I can select one region, I can select two regions, they show up in the list. You can delete stuff out of there, whatever you need to do. There's a few different things here. So you can see I'm in solid mode. You can also extrude surfaces or thin parts. Both SolidWorks and Inventor have the ability to do these things. New creates a new part. This is like creating a new solid in Inventor or turning off merge result in SolidWorks. It just creates a new part, and you can see the part shows up in this list. Add just adds to an existing part. If there are no existing parts, you get an error. You can also use this merge scope box to figure out which parts to merge with. There's relatively similar tools for that, like in SolidWorks or Inventor when you're doing multi-body workflows. Remove just cuts into a part. Once again, you'll have a merge scope you have to select. Intersect does an intersection, which is something you need to do sometimes, but it's typically pretty rare. If you just click OK, you get a part. Onshape just has kind of like some default colors that it assigns to parts, and it rotates through colors. You can change it, which we'll get into here in a second. There are a set of tools pretty similar to every other CAD program in terms of, you've got extrude, you've got revolve, you've got loft, you've got sweep, there's fillets, there's a whole feature, shells, patterns, mirrors. There are slight differences with all of these tools to other CAD programs, but in general, they kind of sit right on the average of about what you'd expect. Buttons are in slightly different places and things are named different, but if you start messing with it, you'll be able to figure it out pretty quickly. There's not a whole lot of game-breaking changes there that you can't figure out, so I'm not going to go into it any more detail than that. I am going to go ahead and create another couple of parts here. Create create like a part here. And I don't know, we'll make a pin that goes in this hole. And then in addition to that, I'm going to create a part here. There's lots of keyboard shortcuts. Unfortunately, the keyboard shortcuts, or at least most of them, are not configurable right now. I'm hoping that that changes in the future. In general, Onshape receives pretty frequent updates, and they have good features in every update. So if there's something that's annoying about it, it's, you know, there's a chance it'll get fixed relatively soon. There's a pretty active community online where you can post in the forums and people can vote on features and new bug fixes and things like that that they want to see done. So if you've got stuff that you want to see, you know, go post over there for sure. You can see all of the parts that I've just created are showing up in this list. The feature tree, you know, shows up just like you'd expect, like in any other CAD program. If I hide parts by clicking on them down here, they hide in the viewport. I can also right click and hit hide all. I can show parts. There's all kinds of different options in this right click menu that you can play around with. Show all parts. There we go. There's more advanced features I'll go over in the Part Studio after I talk about assemblies. So this is all we're going to do for now. So let's hop over to this assembly tab. Now, the first thing we got to do is place parts in our assembly. This works a little differently than Solidworks or Inventor, but in general, it's relatively comparable. If I go to Insert, by default, it's going to be on this Current Document tab. I can click over to Other Documents and place parts from other documents in my assembly. There's also a standard content panel, which allows you to insert screws and washers and other standard pieces of hardware. This is a useful tab we'll go over in a minute. Okay, so by default, you'll see any part studios you have will be expanded like this, and you'll see the individual parts in that part studio, which you can select. If I select the part studio rather than one of the individual parts, it'll just place one of every part in the viewport. Now, if I keep my mouse in this dialog here, by default, it will place the parts in the viewport in the exact same location relative to the origin that they were modeled in the part studio. That is usually a very, very useful feature, so that's something to keep in mind. If I put my mouse in the viewport, the parts will follow my mouse around, and if I click, it'll place them down, right? Just like that. Now, if I do that, these parts are not fastened in any way. They're not fixed. In Inventor, it's called grounding. In SolidWorks, it's called fix or float. In Onshape, it's fix and unfix to have parts locked in place. If I go back to insert, I can click individual parts. They'll follow my mouse around. I can click multiple parts, and they'll both follow my mouse around. If I click, they'll place down. If I stay in the dialog and click OK, they'll just place relative to the origin, but they won't be fixed. So I'm going to delete these. I'm going to do the entire part studio and then click OK. So now what I can do, and I'm going to intentionally do this a bad way first, and then I'll show the right way to do it. If I go through and select all of these and hit fix, they will stay in the correct location relative to the origin in this viewport. I can't click and drag on any of these. Now, if I go back to the part studio and, like, let's say I change the location of this hole, right? I want this to be over here now. And because I've attached this little pin to that part geometry, it moves with the hole, just like you'd expect. If I go back to the assembly, that part moves. Now, the thing to understand about assemblies in Onshape, and this is different than SolidWorks and Inventor. Every assembly you create always acts like a flexible assembly. I believe they're called flexible assemblies in both SolidWorks and Inventor. But essentially, all of the mates and connections that you make between parts in an assembly will be evaluated at every level of the assembly. So if I have a subassembly where there's a part in that subassembly that's not constrained, in SolidWorks and Inventor, if I place that subassembly in a bigger assembly, I can't move that part that's not constrained in that subassembly. I can only move the whole subassembly together unless I specifically select that I want it to be flexible. In Onshape, that's not the case. If there's a part that's not constrained in a subassembly, that part will also not be constrained in the high-level assembly. Now, what this means is that because when you place a subassembly in a bigger assembly, the concept of what fixing a part means is kind of irrelevant, right? It ceases to mean anything when I've got a subassembly, right? These parts are fixed here, but if I create another assembly here and place this subassembly in as a here, so you go to assemblies and you just click on it, you'll notice I can move these parts individual to each other. That was a little laggy. I can move all these parts away from each other, and I kind of break this apart. You'll notice I also can't fix an assembly itself. I can only fix the individual parts. And so this whole way of kind of fixing every part in the subassembly, I'm not actually selecting the subassembly, fixing each of these parts in the subassembly is the wrong way to do it. But that paradigm of like things being evaluated through the whole hierarchy of subassemblies and everything is a very important thing to keep in mind because it acts differently than you would expect coming from SolidWorks or Inventor. So I'm going to unfix these two parts, leave part one fixed. That's totally okay. You've got to have one fixed part in your assembly. And then the correct way to connect these together, like I want these parts to be defined by their locations in the part studio because these parts are connected to each other physically with the feature tree, and so I just want to maintain those locations in the assembly. So I'm going to click this little button up here called Group. A group is a type of mate or constraint. It's a way of attaching parts to each other in an assembly, and all it does is just keep their locations relative to each other constant. It is totally viable to have a part as a member of multiple groups. That's something that I do pretty frequently, so there are some situations where that is useful. And then you'll notice I can't move any of these parts relative to each other. If I go to my assembly and insert the assembly here, the whole thing moves together, right? So I'm going to delete this because I don't really need it anymore. All right, so that is how grouping works in an assembly. In addition, if you have a link, I'm going to place a COTS part here. I'm going to go to Rev Robotics website and just pull a part from an Onshape library there. Let's find a part that has a model. This probably has a model. So if you go to like a publicly available CAD model, for example, and you just copy this link to the page, and then you go to your assembly, hit insert, and then hit other documents, hit the home button, and then paste in this URL box here, and then hit enter, it will show up and you can place it in your assembly and you get the same thing. Like here's the part studio, here's the individual part. This one is configurable, so I can make this shaft shorter if I want to. Click on it. It's gonna have to generate here, but it will insert into your assembly. So that's how you place parts in from an outside library if you have a link to that document or if somebody shares a link with you. In addition to that, there's the MKCAD inserter. This is an add-on that you have to add. You can click parts here. They'll just get dropped on the origin and then let's see. Like if I just click a bearing here, it'll just get dropped at the origin and then I can I can place it. Now, all parts are not in this library, so this is only very common stuff that you can access. I talk about how to add this add-in in the first part of the first CAD week from last summer. I'm going to delete this out though because I don't really need it. Okay, let's dissolve our group here. Let's get rid of our group and let's talk about how to constrain these together in kind of the normal way. They're called constraints in SolidWorks. They're called relationships in Inventor. They're called mates here in Onshape. One of the big things. So this is probably the number one like hurdle to get over in terms of onboarding to Onshape. So the mating of parts together in assemblies is very different from the way that SolidWorks or Inventor or any other CAD program really works. Coming from Inventor, I think you'll have a slightly easier time getting on board with this method of mating parts together. At least I did, because Inventor does have some similar features to the way that mates work in Onshape. Coming from SolidWorks, I hear a lot of people that have trouble with it. So one of the important things to understand is that the kind of philosophy of attaching parts to each other in an assembly in Onshape is that you only place one mate per part, right? Or at least per part-to-part connection. In SolidWorks and Inventor, you will frequently use, 2 or 3 constraints to attach parts to each other. In Onshape, the idea is it's only one. Now, sometimes you'll have some weird geometry, or you'll need to produce some motion in your CAD model or something like that, and you'll need multiple mates to constrain things properly. And they give you all of the tools to be able to do that. We'll go over those briefly in a minute. However, in general, when you're attaching parts together, one mate is your goal. If you're finding yourself needing to use multiple mates, you're probably going about it the wrong way, and you need to look at what your options are in terms of how to mate them differently. If you fight Onshape's way of attaching parts together, you're gonna have a bad time. So it's very important to understand the way that you're intended to attach parts together and then do it that way. Otherwise, you're gonna create a bunch of frustration for yourself. And this is the number one thing that frustrates new Onshape users from what I've seen. So let's talk about it. So in general, Onshape understands that the Onshape philosophy understands that in general, you don't want parts to move relative to each other at all. You want to completely constrain them relative to each other. In addition, you also are primarily going to align things like in very right angle ways, where like you're going to align things to corners, edges, centers of holes. The orientations are going to be 90-degree angles and stuff like that. And so in order to create a set of tools that allow you to constrain things very quickly, a lot of the tools will assume those types of alignments. And then if you have some weirder alignment that you need to create, you do extra work to create these other weird alignments. That's in opposition to like Inventor and SolidWorks, where a lot of the alignments like angles and rotations of round components and things like that that are constrained are undefined, and you have to do extra work to define them, even though every screw that you put in a hole needs to be aligned, in a pretty consistent way. So let's talk about the most basic one, which is called a fastened mate. Essentially, every mate in Onshape connects what are called mate connectors. Now, mate connectors are an entirely, kind of new concept to Onshape in general. Specifically, there are features that are kind of similar in SolidWorks and Inventor in terms of like eye mates in Inventor and I think they're called magnetic mates in SolidWorks. They act kind of similar to that, except they're built in and they're kind of the only way to constrain things. You can create your own mate connectors in Part Studios with, this tool. here. You can also create mate connectors in assemblies as well. That's primarily used for if you're placing them in as a subassembly. Um, these buttons up here create different types of mates. In reality, they just open the same dialog box and they just make a different selection in this dropdown. So I actually usually just hit the M key on my keyboard and then make a selection for the dropdown, but you can do whatever works for you. Okay, so then in this box, you're going to select your mate connectors that you're going to attach to each other. You're going to select two generally. If you hover over parts on your screen, you'll notice I get this little kind of like highlight thing that moves around as I move my mouse. I've got these little nodes that this little colorful thing snaps to. This is the kind of default in like display for selecting a mate connector. Now, the thing to understand is that where exactly my mouse is doesn't actually matter. Where you see this little colorful thing, which is itself a highlight of the mate connector, this is the little symbol that means a mate connector. Wherever this little mate connector shows up on your screen, if I click, that is what it's going to select. So if my mouse is over here or over here or over here, you'll notice the little highlight is not moving. If I click, it will select right where this little mate connector is. You'll notice it's snapping to these little nodes. There's, these little square things for the center of lines, circles for corners. If I get close enough to this circle, it will select the mate connector at the center of this edge. If I zoom in, I can select either endpoint for the for this cylinder. If I hold, if you hover and then you hold Shift, I always forget what this keyboard shortcut is. If you hold Shift, it will not change the face that's selected, and you can select these mate connectors more easily. Shift is a very useful feature there. So like if I want one of the mate connectors that's on this face, I can hold Shift, and then I can move my mouse wherever I want, and I can more easily snap to the things that I want to select. Okay, so let's align this pin in this hole, kind of like we have in the Part Studio. That's pretty easy. So let's select the mate connector at the center of this hole, click, and then go over here to this one and click. You'll notice that it aligns the two mate connectors. There are several different things that I can do. So I can flip the orientation relative to each other using this little button here. And you can see it flips outwards. You could also change the orientation, which with a round part won't be visible, so I'll show later on this block. So in general, the best way to think about a mate connector is you see this little disc, this little like colorful disc at the center of this icon. That disc represents a plane. And then you see this little coordinate triad here. This represents kind of a local coordinate system. Both SolidWorks and Inventor have like user coordinate systems that you can manipulate. A lot of 3D modeling software does. And so this mate connector kind of represents a UCS. In particular, you're interested in the Z-axis. You can see the Z-axis extends from the center of this little disc. The Z-axis represents kind of like the primary axis for Onshape. And so when I'm selecting like round parts and things like that, where there's a very defined axial like direction, the Z-axis is typically going to be what that axial direction is. So when you do a mate, specifically a fasten mate, what it's actually doing is it's lining up these two coordinate systems. And the different types of mates will do this slightly differently. And by manipulating these kind of little buttons and the settings in the mate properties, you will change the way that those two coordinate systems are lined up. Specifically in the mate, I can offset by either of the three axes. Z is going to be the offset that you would normally associate with this type of mate. Like if you're used to SolidWorks or Inventor, Z is going to be kind of the offset you're going to use most often. But I can also offset in the X direction, right, and push this thing off center if I want to. Now, this is what I was talking about before, where Onshape kind of assumes that things are going to be aligned at these kind of orthogonal, like 90-degree angles. Like if you want to go, 0.05 inches at a 30-degree angle, that's not such an easy thing to just put into this box. But that situation will be particularly rare, and there are other things that you can do to make that constraint happen. If you need to, you can create a sketch in your part studio and use that sketch to create a custom mate connector or whatever you need to do. And there's lots of different ways to do that. But typically, if I've got two round parts, I want them to be lined up on the center of the axis. These offsets are going to be 0, and then the offset I care about, might be, like this, right? So that's a quick overview of that one. We'll go ahead and leave this like this, and let's go ahead and do another one just to kind of demonstrate the orientation. So if I want to attach two like kind of prisms together like this is a pretty common case. Generally speaking, the way that you're going to do this in SolidWorks or Inventor is you're going to be selecting flat faces and connecting them to each other, and you would need to do 3 flat face connections to fully constrain this part. Now there is a planar mate in Onshape. This planar mate represents a trap. All right, this is a trap. If you find yourself using a lot of planar mates, you're not understanding how to properly mate things in Onshape. A lot of people coming from SolidWorks or Inventor really want to lean on the planar mate because it's how they're used to mating stuff. You are not supposed to use the planar mate very often. There is a reason that it's not the first one in this list. The reason the fastened one is the first one in this list is because it's the one you should be using most of the time. So once again, just if you find yourself constraining things a lot with planar mates, you need to adjust your method a little bit. Otherwise, you're going to cause yourself frustration down the road. So the way that you could constrain this is by selecting a mate connector on this face, and then selecting a mate connector on this face. And then if I click OK, I can click and drag. Actually, I gotta get out of this tool. I can click and drag on this part and move it around, but it stays planar. Now the thing to understand here, I'm gonna undo that. The thing to understand here, and this threw me off when I first started. Sometimes for some mates, which mate connector you pick doesn't actually matter, which is feels very kind of like wrong when you're doing it. But it just kind of is part of the nature of the mate connector paradigm that Onshape is using. So if I select this mate connector here in the middle, or I select this one in the corner, or I select this one on this edge, right? It doesn't actually matter which one of these I select for a planar mate because they're all on the same plane. Same thing down here. It doesn't actually matter which one of these I select. I'm holding shift, by the way. I can select the one that's in the center of this hole, and it would still do the planar mate correctly. That's just something to keep in mind, is that sometimes you have to pick a specific mate connector, but sometimes it doesn't actually matter which one you pick. I generally just default to the one that's in the middle of the face at that point, just because it feels more like correct to me, but it doesn't actually matter. So let's talk about how to constrain this the way that Onshape wants you to constrain it. Essentially, you should be using mate connectors in the corners, right? If I want to connect this, hover over this face, hold shift, whatever, select this corner one, go up here, select this corner one. You'll notice with these corners, it's very easy to select mate connectors that are on the different faces. If you're careful, you can just start on the face you care about and then slowly approach the corner. And as long as you don't go too far, you'll select the right one. Alternatively, you can hold shift and it becomes a lot easier. And that's how you should do it, right? That's one mate, and this part is completely constrained. I can't move this at all. And I can, copy and paste this and, attach another one. If I want to do something like I want to, oops, I hit the wrong thing. Connect like this corner to that corner. And I want to flip this. And then you can use this orientation button to rotate by 90 degrees and attach that like that. That is how you're going to kind of connect prismatic parts together. That is pretty much as in-depth as I want to go into mate connectors. There's a little bit of a weird thing in both SolidWorks and Inventor. You can typically see the list of parts in your assembly, and then there's like you can expand each of the parts, and then you can see which like mates or constraints or whatever that are a part of that part. Um, in Onshape, you can't do that. All of the mates just show up in this mate features thing in like chronological order. And if I want to access them, I can find them in this list. You can show and hide, and it shows these little icons. If I want to find a mate for a specific part, you're going to actually do that in the viewport. Right click, show mates, and then it'll show this little like icon here. You can right click on it, edit that mate if you want to, or delete it, or show it, or hide it, whatever. If you select this and hit delete, you can also do that, and this part's not connected anymore. And then if you want to hide everything, you can just hide all mates and they'll all disappear again. That's a little bit of an annoying difference. I really wish they would show up under the individual parts, but this show hide mates thing is not too hard to work with usually. All right, let's jump back to our part studio and let's talk about feature scripts. So feature script, singular, is a scripting language essentially that's made for Onshape. And actually the way that it works is that every feature in a part studio is actually written in feature script. So the built-in like extrude tool is actually a feature script. Everything that you see on this bar here is actually a feature script. And behind the scenes, when it's building a part from the feature tree, it's evaluating all these feature script kind of commands to form the geometry that's on your screen. Now, what's really cool about that is that that means that like all of these features and everything are very very easy to kind of upgrade, and you see a lot of updates and new features very easily because feature script is very easy to expand. And that's just on the development side, but feature script allows the user to create custom features. Now, one quick note that I have is that a lot of programs like like we've been talking about, SolidWorks Inventor, both have like VBA support, or they have SDKs that you can use to build plugins, and there are macro features and things like that in a lot of programs. Feature script is not a macro. It kind of like you're building custom features, whatever. It kind of sounds like it might be the same, but it's actually quite a bit different because it's a built-in scripting language that the parts are actually generated with. There is an API or an SDK or something that you can use to build these kind of apps like MKCAD and stuff. There's a separate kind of extension library that you use. I don't really know that a lot about it. I haven't used it before, and that is more for creating things like macros and stuff. And there's like an app store and everything that all of these plugins are put on online. But feature script is a little bit more low level than that. That's just a quick distinction. Okay, so let's model a part here. Let's use a pretty basic one. Oops. Just create a 1x1 rectangle and extrude it. Create a new part. Make this like 6 inches long. So your custom features, your feature scripts will show up in this little drop down here. Now, depending on the resolution of your screen, these buttons will kind of be hidden or rearranged or whatever. Some of them will be visible, some of them won't. If you have a button you can't find, you can click in this little search bar and search for tools by name. I actually use this all the time because even these icons, sometimes I get lost of which one is which, and it's just faster to go in here, type the first 3 letters of the tool, than try to find it in the bar if it's a feature I don't use very often. So for your feature scripts, you can hit this drop down. Now, you can add more. Essentially, these are each of these feature scripts are actually a document. If I go down here to this little plus and hit create feature studio, this is the like coding environment where you actually write your own custom feature. If you want to do that, it's I will say I have written my own features. There's a bit of a learning curve to it. The way that the script works is a little strange, but it is quite powerful once you get used to it. Um, the way that these typically are structured is that the um, the feature is written in its own document, and then that document is shared with a link, right? And I go over this. I don't actually remember if it was in the first part. I believe it was the first part of the first week of the CAD class. It may be part two. But if you want to go check out how these are added and you want to see my recommendations for which ones you should add, you should essentially get all of the ones that are in this list. I talk about how to add that. So I'm not going to go into that here. We're going to just use one of these. I'm going to use this one called the tube converter. And I actually need to update this because it's been a while since I've used this account. So I'm going to right click on it and hit update. And I'll just let it update all of them. Okay, so there should be, that's what this little icon means. It means that they need to be updated to the latest version. Done with all that. Okay, so let's use the tube converter here. Now you'll notice this opens up a dialog. Now this dialog looks very similar to all the other dialogues you'll see, and this is kind of what I alluded to earlier in the video. All of these dialogues are actually generated by the feature script. You kind of specify this dialog as part of the feature. And so all the dialogues are very consistent. All these tools act the same way across custom features and built-in features, which is super nice. So you get this dialog. Essentially what this thing does is you just model a rectangle that represents like a piece of box tubing, and you just click on it, and then you specify, the wall thickness. In our case, I want to do a max tube, and it'll overwrite most of the settings and just do a max tube. Click OK, and like it did all this complicated geometry in one click. And so this particular feature is super, super useful. I highly recommend if you're modeling robots that are made out of box tubing, just use the tube converter. Model your kind of rectangular prisms and then just convert them to tubes. Don't try to model the tubes in Onshape. And obviously, you can imagine how much time this saves you across the whole robot. Okay, so I mentioned adding feature scripts is done by link through here, and you can reference the other video if you want to see those. I mentioned that each feature script is typically developed in a document. Sometimes you'll have multiple features in a document, and that's just up to the developer, however they want to organize them. If you see a model that's public, and say you're browsing through a model and you see a cool feature that somebody used that you don't have, you can get access to that pretty easily. So if you have access to the feature tree, you can right click on a feature and hit open linked document, and it'll open a tab to this particular feature script. And this is all the code and stuff. Specifically, this document has a lot of Julia's feature scripts in it. These are all super great. I have pretty much all of them on my personal account. They're all really useful. I use them all the time. But you can just copy this link and add it, the same way you would add any other custom feature. And so this is how you can kind of get access to feature scripts that you just find in other people's CAD models, which is just another kind of nice feature of the kind of cloud-based, everything's shareable online aspect of Onshape. All right, that's all I have to say about feature scripts right now. There's obviously a ton of ability here, and really just up to which feature scripts you choose to use, and the kind of use case of each one will differ. So, that's definitely outside the scope of this video. Let's move on to one more thing before we wrap up here, which is the kind of version control aspect of Onshape. So if we go up to this button up here, which is versions and history, and we click on it, we get essentially a list of every change that we've made to this document. So if I expand this, everything I've been doing throughout the course of this video is here. And this history will go back to the beginning of the creation of the document. As far as I'm aware, this history never gets deleted. Like you have access to this for all of the time that the document exists. Now let's say that the state that this document is in is something I'm happy with, and I'm calling this kind of like a stopping point or a milestone in the design. What I can do is I can click this button here, or create version, or if I'm this in this like panel here, I can click the create version button up here, and I can create kind of a save point. Now, it's important to note what a version is a little bit difficult to explain, but it's not actually a save point. The document just saves as you work, just like most other cloud apps do. But um, a version is kind of like a commit um, in like Git, um, but it's also a little bit more significant than that. Typically with commits, you'll do like a lot of commits, and some commits will be kind of in the middle of some work depending on what you're doing. Versions are maybe a little bit more formal than that. Versions are typically something more akin to a release. It's something that you want people outside of that document to be able to see. So in the case of an FRC robot, you would create a version at any point where you want somebody to be able to update your subsystem on the top level assembly. Right. So like if you're in the middle of something and you've got parts suppressed and things are exploded, you probably shouldn't create a version there because that's not a very good stable place to give access to people. If you're working on a document and that document is public, the public will only be able to see the last version that you created. So it's possible for you to be working on your design and people can be using the last stable version of your model. And then when you've got it to the point where you're happy with it, you can push a new version out by just creating a version. You can name the versions. I typically, my approach is generally create a lot of versions. As long as the model isn't super broken, it's okay to create a version anytime you reach kind of a stopping point. Especially versions are also a lot easier to go back to. I'm gonna go ahead and create this just called V1. I can go to any point here. I can rewind to any of these places, but it's a whole lot easier to work with versions rather than these individual actions here. In addition, versions are used as a starting point for a branch. So let's do a quick example here. So let's say in this part studio. In case it wasn't obvious, I didn't actually mention it, but your versions and everything are for the entire document, not just for an individual part studio or assembly or something like that. Let's do this. All right, let's create a branch. If you right click on a version, you can't right click on main. You have to right click on a version to create a branch. Branch one is fine. Let's copy this part. Oops. Let's place this part. And then let's do a group where we group these two things together. And then let's place an extra one in here somewhere. Gonna mate this. Like that. Okay. All right, so that's my branch. And then one thing to understand is when you create versions in a branch, it's going to kind of sort things in this list by what's the last version you created. So that's just something to be aware of. Now, if I go back to main, you'll notice I'm in my assembly, and that part's not here. So let's like create another block up here, and let's just like stack this block on top of this one. And let's say these two states here, main and branch one, both represent like two different design pathways for your design. Now let's say you get down the road and you're like, actually, this design is way better than this design, and I want to bring branch one into main. This works similarly to the way that like a Git workflow does in software. You select the one that you want to merge into, and you're basically pulling the branch towards yourself to merge the branch. So I can right click on this, hit merge into current workspace. Now it gives you several options here. So I can do one of three things. I can merge the changes from both. This is not always an option, right? If I delete a part and edit a part, I obviously can't, in two different branches, I can't merge those together, right? I have to pick one or the other. In our case, um, we added parts in the assembly, and so we can actually add all of that stuff. We don't have to keep only one necessarily. Now, in my example where I said, oh, I want the two tubes to be merged in, I want to replace with B1, but I can absolutely merge changes from both. We'll just hit replace from B1 and hit merge, and then main will update. I typically create a version after I do this, and I typically name that version something like merge this into that, just to make it extra clear, because you'll notice that it doesn't actually automatically create a version when you merge. This is a little different from the way that Git usually works, as I understand, is it automatically creates a commit usually. But yeah, this is essentially how merging works in Onshape. So in addition to that, let's talk about sharing a little bit. So let's go ahead and create a version. I'll just call it merged. Super bad naming convention. All right, so then if I go up to share, there's several different options here. So I can share with individuals, like through their emails. I can share with teams. By default, if you create a document in like a team, a folder that's shared with a team, it'll automatically share it with that team. So generally speaking, like if you create a folder for your 2024 robot or whatever, it will just automatically share it with the team, so you don't have to worry about this. You can make documents public. If you make documents public, they will only be able to use that document if there's a version that they'll be able to access the latest version. You can share things with applications, which, like in this case, MKCAD has permission to access my documents, which is important for it being able to like insert parts. And then link sharing is also a thing. Something to understand about link sharing does not require that users be logged in. So this is super useful for like, you want to share your robot design on Chief Delphi and you want people to just click on it and look at it. You definitely want to link share that. Making it public makes it so that everyone can access it, but they have to be logged in, which is just an extra step that's really annoying and prevents people from like quickly accessing your documents. So if you're sharing things and you really want them to be accessible and viewable, you definitely want to do link sharing. That is pretty much all I've got. The thing to understand as well is if you've got multiple documents and you're putting them together, you'll have to manually update every time you push new versions. Like at the top level of your robot, you'll have to go into the top level and update your subassemblies every time you push new versions from the bottom. But we're going to do, like I said earlier, probably we're going to do a video about how to kind of organize robot projects in quite a bit more detail. So I don't really want to go into that in this video. But that's all I've got. So thank you for watching, and I'll see you in the next one.